So everyone, this is Alex. This is a talk on the, is it Wyvern programming language?
Yep, good,
Good,
excellent.
good.
So today I'm going to talk about Wyvern and in particular about how to design a programming language with security in mind. It's a research project we've been working on for the last probably 7 or 8 years, mostly between myself and my colleague at CMU called Jonathan Aldrich. So as we know, software security is a big problem. Every time I give this kind of talk, I go to some news websites, and every time within the last few days, you can find a whole bunch of news that affect our everyday lives. I mean, right now, in the last few days, apparently there is a big update to Windows. A couple of our health services are crippled in New Zealand and several of our schools. It brings a question of why systems are still vulnerable. After all, we are supposed to know how to code securely. We follow the rules. There is cert advice. There is at CMU in particular, some organization called Software Engineering Institute that has software engineering written in stone, literally outside, with a lot of instructions on how to code securely. There is Oracle guidelines for Java, various technical advances such as types, memory safety, etc. And yet we still fail too often. Now, there are several causes that we think are in place. One of it is that a lot of the time people concentrate on the code in a particular aspect of their system rather than engineering the entire system. And often languages do not necessarily support the architectural level support for these kind of important design decisions. There is, of course, also human limitations, and some of the tools can be rather unusable. Say for the information flow for Java, there are a number of tools that can be used. GIF comes to mind, but they're not easy to use for even advanced developers. So what we are going to try to do with Wyvern, and that's what I'm going to try to demonstrate in the talk using a couple of decisions we made in the language design perspective, is try to enforce this architecture level security in a usable manner. And I'll explain what I mean in this talk. So we're aiming for secure systems development. We're going to take a very high level perspective of the entire system. Think about architecture, software architecture. And we're going to also take into account that programmers are humans and want to make tools in such a way that are easy to use as a programming language user. We also obviously will use a lot of the existing work in programming languages, which brings in the actual advances that we are applying in Wyvern when we put the language together. So this is the motivation behind our language. There is a website, Wyvern, and it's basically designed in such a way that when you make every single language design decision, rather than picking things like productivity or often performance, which saves people money, we put security first and see where it will get us. Because we're researchers, we can afford to design a language in a way that we see fit, rather than necessarily to, say, make money or make products that we eventually want to learn from, but it's more of a thought experiment with implementation. It's general purpose language. We emphasize web, mobile as the usual sort of modern world. And you can actually download and use it to the state that it is currently working as. Now, you may ask, there is a trade-off. You can have a very secure system that you can develop. You can have formal verification tools. You can verify everything you do in tools like Coq or other favorite verification sort of environment that you may choose instead. Or you can be extremely productive and not worry about what the language guarantees and create great systems really quickly. Python is another language that can come to mind. Or you can sort of try to balance it out and maybe add some static typing among other things and make a more reliable system, perhaps the way that Crystal does compared to Ruby, or perhaps the way that Java does it compared to Python or something like that. So isn't it an inherent trade-off? How can Wyvern sort of find the right place to be? You see yourself making these kind of trade-offs. I mean, in particular with Crystal and Ruby, when it comes to static typing introduction, it reminds me of this picture. If you've ever seen this kind of thing before, you can pause and watch it later. There are different advantages to, using one versus the other. So what trade-off Wyvern makes and brings in usability is sort of try to find decisions, and I will show you two of them, that sort of shift yourself towards introducing more security in a usable manner, which we think will introduce productivity improvements as well. So what does it mean? We are designing a programming language, which means we are trying to help programmers express the kind of decisions that we think are important to security, and then hopefully enforce these design decisions, which is basically like static typing, checking things at compile time. So we built our security mechanisms, but keep in mind the thing called language usability principles. There is actually quite a lot of work out there in the last 10 years, including Plateau series of workshops specifically on programming language usability, which is not just the kind of thing you normally think of when it comes to user interfaces, etc. So here is an example of a hello world program in our language. Every language sort of starts up with that to make sure that we don't have public, static, void, main, all of those stuff. As you can see, there is slight difference compared to other languages that comes up straight away. We have require std out, which is basically a capability that is passed to the main program here that would allow it to then, if it's given such a capability, to use it to do things like print things out, like print hello world in this case. We use indentation in case you're wondering, so we don't need to use semicolons, so all of that stuff may be familiar to you. So example number one, I'll give two examples. You're all familiar with, say, SQL Command Injection. You've probably seen this XKCD comic many times before. If not, you can pause and read it later about Bobby drop tables. And one would say, well, it's a solved problem. You can do it in Java-like language like this. You can use prepared statements. It's the kind of thing that often OWASP and other security advisories sort of highlight and require people to do. You can do select star from students, and when it comes to actually inserting some user input, you will use a placeholder that you can then fill in the hole with the actual username in the right place. Well, it is a little bit verbose, to say the least, to write all of this just to insert the name for the student. You are still manipulating strings, and at the end of the day, the language is not really helping you much here. It is basically just breaking up a string into the right order of elements and then manually inserting the variables in the right place. So IDE may not understand what you are doing or highlight it in the right way. There may not be type checking, etc. So that's where we say, well, this is not the most usable way of forcing people to do this. How would Wyvern do that? Just as a sake of an example, this is what it looks like in Wyvern. So you execute a query. There is a little bit of detail going on here, but basically everything that is followed the tilde sign in the argument for execute query is actually expected to be of type SQL query. So everything that is offset to the right is passed to the SQL type to be parsed and dealt with appropriately, including going back to the original language, where student name is going to be able to be extracted from the actual Wyvern variable. So it is what we call a type-specific language rather than domain-specific language, where we are allowing the user not to treat it as a string. It is all part of different programming languages involved, domain-specific languages involved, more likely. And we provide the way where the system itself will still do the right the right thing in terms of checking that the student name is a variable and not at any point treating it as a string part of the query. And yet to the programmer, it looks very little different from the original SQL query that would have caused the kind of SQL injection problem to begin with. So we're aiming to create a more natural yet secure version. Now, how would you do that? Isn't there going to be a number of issues when you try to combine especially multiple languages like that? Language extensions, in fact, have been tried. There is various libraries you can look up. SugarJ, SugarStar started some of this work, and there is a lot of generative languages designed. One of the problems people also face in this setup when mixing different languages is questions like, is it XML or HTML if you're going to try to use both in the same file that you are parsing? The nice thing about doing it in the type-specific manner is that what we do fundamentally in Wyvern is we use the expected type at every point to figure out what is the appropriate parser to use. In fact, the parser is imported together with importing of the type. So that's what import metadata in Wyvern means. So together with XML or HTML type, you will import the actual parser associated with it. So when you then declare a variable snippet, because we know it's of type XML, everything passed to that variable to parsed will be known to be given to XML parser to actually interpret. There is never confusion about what language you're currently using. The syntax of language in the way that it is set up is completely unrestricted. The indentation in this particular case is what separates it from the host language, but there is also ways to nest different languages using the right matching symbols. Again, there is obviously a whole 1 hour's worth of talk on detail of how it works, but the ultimate solution is that you are going to be able, together with your type, declare a parser that will be given to the Wyvern parser and will basically convert any text with very little restrictions on what it can look like other than indented, for example, in the case of tilde, to a part of the Wyvern syntax tree. So that means type checking and parsing is going to happen at the same time. You may want to question then, why is it that you're allowing someone to write actual code during compile time of your program from the security perspective? But the good news about Wyvern is that it uses immutability, among other things, that we learned from the good secure languages, and you can actually restrict, using capabilities and immutability, what your extension to the parser and the type can do, so that it's a purely functional extension that can't just suddenly go off and read something on the network and read what it's currently working with and send it somewhere else. And this is how the code in Wyvern would look like, where the connection is going to be established. The student name will be gotten from some dangerous place, such as input. And then you can see the actual Wyvern executing the query that is then given to the SQL metadata to parse, and then using this to matching parentheses going back out to the Wyvern language surrounding it to actually process and get the value of the student name. That SQL query will then, in one place where it's doing the parser, figure out how to check for any sort of validation, avoiding injections, sanitization, etc. You don't need to worry about everywhere in your code worrying about sanitization and things like that. It will all be just safely done in one place, which defines, in this case, the SQL type. You can also add additional things. You can start validating things against particular schema for particular subtype of SQL and do a whole bunch of things that are normally completely extracted from your language while working within the same language, which is in this case Wyvern, so one language to put them all together. And yet the SQL extension itself will have access to any other outside languages, including the host language variables, etc. So here is the ultimate sort of example you can come up with, separating different languages by colors, where you can imagine a serve function that is given a URL that uses its own type-specific language for URLs, and then given the actual HTML that uses the type-specific language for HTML in green, that may perhaps then indent, as you can see, out to a CSS language, going back to variables in Wyvern, and the same thing with the SQL query in the right places. And yet, to a programmer, this looks like good old, maybe even PHP, if you ever remember that kind of server-side code, where everything is a string and dangerous, but it's not. So that's sort of, there's a lot of details here that I can, there's papers that we published on this that I can point you at later on, but that gives you an idea of putting this usability and security together so that our domain-specific language support in Wyvern uses the actual engineering of how to use this domain-specific language to express the particular aspects of the design, yet doing it in a natural way that IDEs can support your mixed languages and making it usable. And we simply use the existing programming language research about variable hygiene, type safety, conflict-free extensions, etc., to actually put it together in the way we think that may work in a good way to advance that trade-off curve. So a second example of the two that I'm going to talk about now quickly is to do with what we do with capabilities. So here is an old idea. I mean, if you read any sort of classic architecture book or any instructions, or perhaps something you learned in your software engineering courses, you know about layered architectures, where you try to put your unsafe low-level file access library or whatever at the bottom, and then have some sort of nice high-level framework, and ask all applications to go through that framework and never bypass it to go directly and do something that you would consider dangerous. It's ideas from the 1960s, Dijkstra wrote papers on it, etc. So the lowest layer is this unsafe library, middle layer is some sort of framework, and then the application is supposed to just use that middle layer and obey strict layering. Any sort of networking framework is a good example of many layered implementation. You can imagine a SQL access library that hides it behind some high-level library, perhaps replicated storage, etc. So the question that we had is, well, can you enforce this kind of architectural decisions in the language? In particular, can we use capabilities to enforce such layered access to resources? So here is an example, and also the idea of what is meant by this kind of layered architecture is something that you might have heard as principle of least privilege. Again, the idea is, as everything in computer science always comes from 50, 60 years ago, the idea is that modules must only be able to access the resources necessary for whatever the purpose the module has, and no more. So in Wyvern, if we are going to talk about SQL still, let's imagine we'll have a string SQL library that is actually doing some manipulation directly with the strings, and we'll consider it a low-level dangerous thing. We then treat it as a module that needs to be given to you, and such module is treated as a capability. That's why in our language, instead of import, we say require keyword for the capabilities. That means that when we write the rest of the code, when application will run, we know that it will have to be given such a capability to be able to execute what it wants to do. The idea is that at the center of your application, you can actually construct the architecture in such a way that if you haven't been given a capability to do something, it is actually impossible for you to go off and say, directly talk to a database or things like that. Often, even in an enterprise kind of environment, I think even in enterprise Java beans, if you ever remember that kind of setting, if you want to access something over the network, well, you just import Java network and you access something over the network. There is complicated things like Java security model, etc., that sort of try to check if you've actually been eventually given that permission, given the method calls that arrive there. But there is no obvious way to sort of import, to stop someone from just importing what they need, the library that may have nothing to do with what this code does. In Wyvern, with the way it's set up, it is not possible to do anything unless you were given a capability to do so. So if the file capability is never mentioned, you can't access files no matter what you try. You can look at Mark Miller's work on capabilities and the E programming language. That's what this is inspired by, as a quite a big and interesting programming language related research area. So to set up now the layered architecture that we are talking about, what you will do is, all right, we know that we require this string SQL capability. We then set up the middle bit, which is the safe SQL high-level framework, and we give that capability to it, and we'll put it into an SQL variable. Remember, our modules are just first class here, so we just put them in variables. And then the application itself will only be given the SQL, not the SQL dangerous library called string SQL. Now, the point here is that this is non-transitive. So the SQL application can then be checked that it has no access whatsoever to string SQL at all. You basically distinguish between the two as you set up the whole scenario by having the require for the capabilities and import for any code that you may want to use. Then once you've instantiated the right structure, you pass it down to the SQL application as a sort of normal code that meets whatever requirements of the safe SQL API, and then you actually write the application code. When you look at the blue part at the top, SQL application has no need to access the actual string SQL, the dangerous one. It's only the main part that actually has it originally, and that's the one that only gives it to a safe SQL, which then has to take a responsibility to doing the right things and implement perhaps an ADT in terms of strings and have the extra parser added from the previous example, et cetera, to work with the SQL. And so one would ask, well, isn't that going to make my programming really, really hard because I have to link it all up and think through all of these things? Well, as we were writing some of the libraries for Wyvern and the actual code itself, we found that majority of modules in Wyvern didn't even need to have state. And if they don't have state, they're not capability-like and not something we care about. In fact, we call such types with state resource types, and types without state you can talk about as sort of pure or functional types. And most modules don't have state, which means that they can be imported by anyone without worrying that you are going to break something. The only thing you start worrying about is stateful modules. They're the same as objects for us, or what we call resource types, such as perhaps file system access or things that come with the ability to access the operating system or use a foreign function interface. So most modules can actually be declared as pure, and they can still generate things that are stateful. So in this case, you have a type set in here that itself is pure, but it can have a make set method that will return a resource type set. And then you can have things that actually work with an operating system, perhaps a file type that will be a resource type or a network type. And you can put them together in such a way where the resources will always have to be passed in. So you declare a part of your module in such a way that, hey, in this case, it's a module being defined called client that has to have a file resource passed to it. But the rest you can just import because they are not actually resources. You can then basically see that the way that we are doing it, and I'm also, because of the shortness of this talk, skipping the part that we do with effects in addition to capabilities, which I can expand upon in Discord or in another time, where we actually try to enforce these architectural restrictions on how you can work with resources in your language in such a way that makes it easier to use. Now, usability actually comes from the fact that we allow to put more granular restrictions than capabilities only. We put the effects, so think distinguishing file write versus file read. And we also allow the abstraction to happen between these effects where, well, the logger perhaps is going to just perform a log operation. You don't need to know that underneath it, there is actual file write going on. And we think that's quite an important thing. We think every language, in fact, needs to use capabilities to be able to make security guarantees. And what we've spent a lot of time doing is making Wyvern in such a way that you can actually use these capabilities without costing you quite a lot of time to understand what are restrictions on your system. So that's the 20-minute version of this talk, and I'm happy to stay in Discord and expand with some examples of either capabilities or effects. So that's it. You can also ask me questions later. I have a Twitter at the bottom. Thank you very much.
Awesome. Thank you. Actually, this mic has changed. Can you still hear me?
Yeah, I can hear you.
Awesome. Good. All right. Thank you so much for this talk. This has been pretty interesting. I'm not sure I fully understand it. I'm going to have to rewatch it to make sure I get it all. But thank you so much. Beta says, thanks for the nice talk. How far is Wyvern from a production language?
You can compile and run code. So here, I'll show you something. Let me see, new share. Actually, screen one will do. So can you see my screen?
Yes.
So here's some examples. You can actually go to the website and download Wyvern. So here is your hello Wyvern. Oops, sorry, that's actually doing a lot more than hello Wyvern. But to show you that it actually compiles, I was playing with it, unfortunately. It does, and you can build it. It is written in Java, and there is a small part written in Wyvern itself towards self-hosting. But it also can talk to JavaScript, Python, and Java, so 3 possible sort of languages that it can cooperate with. Here is an example with effects that is open already. You can imagine a module at the top defined for the files that gets the Java as a sort of way to interoperate that is marked with effect system FFI. Okay. Here is an example of a network. It's an alternative one that has similar signature. And here is a logger that will log either to network or file, but it abstracts away by saying whatever resource you give me, I'm going to have a write effect declared at the logger time. You can then imagine putting together an editor, a very simple one. There is a bigger example of this too, where the main part over here sets the logger to be a file logger and abstracts away by, say, getting a plugin, perhaps, doesn't matter if it's characters plugin, that will be using a file logger, or you can choose to use a network logger. And Wyvern allows you to actually set it up in such a way that if you look at the actual plugin code, plugin will not be able to do any more than actually operate with the logger. It wouldn't be able to write to files, it wouldn't be able to write to a network, even though underneath it's going to use either file or network library because it's non-transitive. And all of this code obviously can be compiled and run sort of, so it's not production ready in a sense that it needs a lot of work. We don't have a team of programmers to get all the bugs out, but it has been as much ready as me and Jonathan and a couple of students now and again appearing can get it to. It's a research language. All right. Thank you.
Yeah, that makes sense. That was Beta's real question. I have a quick question for you, which is, can this be implemented with Crystal's module?
So you can do foreign function interface with, good question. If you were to talk to, you can write, yes. So the answer is yes, but it's with a star. You can basically do foreign function interface like talking. So you write the top level application, say in Wyvern, and then call out to the Crystal bits that are written in parts of it and help enforce your Crystal architecture using the Wyvern ability to check for capabilities. It is possible. We've done it before for a new language like JavaScript when we brought it in. So we can, but it's a yes with a star. It's not just off the shelf.
Okay, yeah, that'd be very interesting. Obviously,
so that can be a nice project to do where you can enforce architectural level decision for something like Crystal. Yes.
Okay, and then we have like 2 minutes left, so I'm going to finish off with Ryan's question. Do extensions have to be implemented in Wyvern, or can you wrap foreign parsers and use them? I think we might have kind of answered that with Crystal and use them in your Wyvern code.
So to fit into the Wyvern IST, you need to have written it in Wyvern to actually, but the thing is that you can then call out from that parser to another code, but you have to be careful when it comes to immutability. So it's a yes with a star again. But if you do it in Wyvern, no problem. But if you use it to another language, it is possible, but there is some caveats. And we can discuss in a longer version. So that's it. I think you need to finish in a minute.
Awesome. We're going to start bringing in the next panelist here. And thank you so much. This was a very interesting talk. This is definitely one I'm going to have to watch twice. but thank you. And
thank you very much.
It was nice having you. Yeah.